In this lesson, we're going to provide an overview of port channels on Arista switches. Port channels and LACP, Link Aggregation Control Protocol, also known as 802.3AD, are covered in Arista's configuration guide. A port channel is a component made up of two or more physical interfaces of the same media and the same speeds. These interfaces are combined to form one logical interface. It is common for folks to refer to port channels by their relevant protocol, which is LACP, the Link Aggregation Control Protocol. In my lab, I have two switches, switch 1 and switch 2. They're connected via several sets of physical interfaces. I haven't configured the port channel on switch 1 yet, but let's look at the physical interfaces and port channel configuration on switch 2. So if we issue the command show run interface Ethernet 1, enter, we can see that this is switch port mode trunk and then channel group 10 mode and active. And then we'll do the same for show run interface of Ethernet 2 and hit enter. And this physical interface is configured the same. Switch port mode trunk, channel group 10 mode active. And then finally, let's look at the port channel, show run interface port channel 10, enter. And we can see this is also a switch port mode trunk. The logical bundling of physical interfaces provides for increased throughput and resiliency. You configure port channel interfaces in pretty much the same way as you configure physical interfaces, with the few exceptions that may come up in regards to the additional features. Port channels, or port channel interfaces, can run as layer 2 or layer 3 interfaces. The underlying protocol used to manage these port channel interfaces is the IEEE's 802.3AD, also called LACP. LACP is an industry standard protocol and isn't reserved to just switches. Hosts, servers, firewalls, and load balancers are examples of other data center devices that often run LACP. There are a few modes in which you'll configure LACP as either active, passive, or simply on. So let's exit off of switch 2 here and move over to our switch 1 and configure our Ethernet 1 and Ethernet 2 into port channel 10. So we'll get into configuration mode, we'll type config, enter, and then interface Ethernet 1, enter. And we're going to make this a trunk port. So switch port, enter, switch port mode trunk, enter. And then to put it in the channel group or the port channel, the command is channel group space and then our group ID. So we're going to call this port channel 10. And then we type mode and question mark. And this is where we see we have our options of active, on, and passive. These modes are configured on each end of the LACP bundle, and depending on how each device is configured, will dictate the LACP negotiation. For instance, if you have LACP in active mode on both devices at either end of the connection, then the links will be combined or aggregated when the LACP negotiation succeeds. If you have LACP in active mode on one end and passive mode on the other end, then the links will be combined or aggregated when the LACP negotiation succeeds after the one set to passive reacts to receiving LACP PDUs from the one set to active. If you configure both ends to be passive, then you've effectively negated LACP. And the links may or may not aggregate depending on the device's specific implementation, so it's important to read each vendor's documentation. So what do we mean by active and passive? Active means that the device's interfaces actively send LACP PDUs or protocol data units. Passive means the device's interfaces only send LACP PDUs when they see LACP PDUs coming from the device at the other end of the connection. So active means they repeatedly send LACP PDUs and actively try to establish a port channel, where passive means they idly wait to see if the other end is going to send any LACP PDUs. Within the LACP negotiation, there exists the concept of verifying the system ID of the peering device. The system priority is used in combination with the system MAC address to create a unique system ID. In global configuration mode, you can alter a switch's system priority. The system ID is important because neighboring LACP devices use that to ensure that all interfaces are connected to the same device. There is also the concept of an LACP port priority. This value is leveraged when you need to run interfaces of your port channel in fallback mode. And it's interesting to note that interfaces assigned a lower numerical value actually are treated as a higher priority. On Arista switches, the interfaces will send their LACP PDUs every second. Once the links are established and synchronization between the switches is complete, they throttle that rate down a bit to once every 30 seconds. With intervals of every 30 seconds, it takes about 90 seconds for the links to determine there is a problem and to mark the neighbor as failed in regards to LACP. This would mean some form of malfunction with the protocol or the switch itself. Fault detection and subsequent failover is much faster when the interface actually fails. So the slower interval and timeout period is provided as a secondary precaution to an actual link down event. It is generally considered good practice to use an even number of interfaces bundled into a port channel. Good practice, but not a hard set requirement. The general consensus is that perhaps better load sharing can be achieved if an even number of interfaces comprise the port channel. Arista switches use a hash to determine which interface or interfaces, frames, and packets should be transmitted. Arista provides the option to base this hash on multiple fields of a frame or packet, including IP and MAC addresses. You may see in the output of the show interface port channel 10 that there is something called fallback. Fallback mode comes in handy when you have servers that need to get their configuration from another device. So let's finish this config here. Mode active. Interface Ethernet 2, switch port mode trunk, channel dash group 10, mode active, enter. And then let's get into our interface port channel to look at this fallback option. So interface port channel 10, enter. And if we type port dash channel and question mark, we see we have the option for LACP and then also to declare the minimum number of links. So let's focus on LACP space question mark. And here we see the fallback option. I mentioned fallback is used for connections to devices that don't necessarily have their full and final configuration when they boot up, that they require or acquire their configuration from somewhere else. A common example is a server that uses PixieBoot or ZTP, Zero Touch Provisioning, to get its configuration from another device, like a TFTP server or a jump server. In fallback, a device can keep its LACP relationship up and active even if the device on the other end is not sending LACP PDUs. This provides added bandwidth and resiliency while we wait for the connected device to come up with its full configuration. As with most Arista features, port channels and the use of LACP are industry standard. Added bandwidth and network resiliency are reasons why we run port channels at either layer 2 or layer 3 between switches, routers, firewalls, load balancers, and servers.